Journalist Matthew Griffin, better known as the Fanatical Futurist. Thank you for everything that you've been doing with the Fanatical Futurist YouTube channel recently. We reached 320,000 subscribers recently. And YouTube even sent me a nice little plaque. That's it, which frankly, I have no idea where to actually put it. So it's kind of just stuck on my desk at the moment. But thank you very much. Now, in this particular vlog, what we're going to do is we're going to have a look at the past 12 days of futures news. Now, if you watch my blogs regularly, you'll know basically that I quite often say that the future is being created and shaped today. Now, what I actually mean by that is the breakthroughs, the technology developments, and the technology innovations and things basically that we are actually creating today ultimately, if we can get all of the different things right, such as scaling the technologies, we're getting them commercialized, getting them to be mass adopted, etc., over the next 1, 2, 3, 5, 10, 20, 30, 40, 50 years could actually end up becoming all of our status quo. So if we really want to be able to predict basically what the future might look like, or at least theorize what the future might look like, then in my opinion, you need to have a decent grasp of all of the different technology developments that are actually happening today and all of the emerging technologies that are actually coming through today. Because you take all these different technologies, you combine and converge them together, and that gives you the next generation products and services. So, what have we got? Now, this, I say this week, kind of this sort of past 12 days, these are all on the fanaticalfuturist.com website. So if you go there, you can actually dig into all of these different things. Now, when we actually have a look at Huawei, so Huawei recently unveiled a trifold smartphone. It's valued at about $2,800. They allegedly had millions of back orders, which actually makes it one of their fastest, I say fastest growing lines, but sort of in most demand lines. When we actually have a look at Apple, for example, I mean, Apple recently unveiled a couple of new bits and bobs in iPhones and everything else. Huawei is smashing Apple. And increasingly, this is this is actually one of the reasons basically why Apple are now floundering in China. So Huawei, I've done a lot of work with Huawei in the past. They look up to 50 years out at the future of different technologies. They spend $15 billion a year on research and development, and they do not want to be disrupted. Bearing in mind that they are the embodiment of companies, that have been disrupted because a lot of their products and services have actually been banned throughout Europe, the US, like their 5G networks and so on and so forth. So Huawei is increasingly upping the ante when it comes to developing high-end smartphones that are packed full of the latest technologies, whether that is actually the screens, the physical technologies, or the digital technologies like artificial intelligence and the chipsets that go into these things. So, in my opinion, even though Huawei hit the news because they released a trifold smartphone, the fact of the matter is they will just come to dominate the Chinese market. And then they've also got their Harmony OS, which is like the Google Play Store. In my opinion, I don't really see why Huawei, with what they're doing at the moment, couldn't become a $1 trillion market cap company. And the whole story about Huawei is insane. They are the case study in how to avoid disruption. Anyway, that's them. Now, I've been doing a lot of work recently on the future of risk, cyber, and security. And this is an Israeli sort of piece of research. So, Israeli researchers, as well as American researchers, have actually figured out that they can recompile what you are actually watching right now or looking at right now, basically on your computer monitor, by using sound. Now, if this sounds odd, it's not the first kind of audio attack or exfiltration that I've actually seen. We can actually use sound to get your fingerprints. So Google that, and that'll be in the article. Go and have a look at the article. Now, to explain this one a little bit, when your monitor is on, like it might be now, hopefully, it's making a noise. So all of the different pixels within your monitor make a particular noise, and the stronger the noise, it's probably a white pixel. You know, if there's no noise from an individual pixel, then that's probably because it's black. And then we go all the way in between through the RGB spectrum. Using artificial intelligence and audio, these researchers, with a 90% level of accuracy, have been able to use AI to recreate what is being shown on your screen. Now imagine that as a mode of attack. Now, we can defend against this attack actually by using white noise and introducing white noise into monitors and speaker systems and so on and so forth. But this is just another example of how, I say how insecure our digital world is, and just how imaginative hackers actually are. Now, this one, when we have a look at the healthcare space, so Elon Musk, via his company Neuralink, has been developing implantable brain chips. Now, on the one hand, these brain chips have been used to help monkeys play Pong and pigs surf the internet. I mean, come on. I mean, that's great. Yeah, this stuff's crazy. This is my world, by the way. So this is the crazy world that I actually bloody live in. But in this particular case, Elon Musk's Neuralink has created something called Blind Sight, and it has got regulatory approval from the FDA now. Essentially, this is the use of an implanted brain chip to help people restore their sight via their optical nerves naturally. So it's actually a really big deal. I mean, when we have a look at blindness, we've also been able to use stem cells to cure genetically inherited blindness as well, which don't require brain chips. So there are a couple of different ways that we've actually, we're solving blindness today. Now, when we have a look at this next one, so this again, Bessie, is a brain-machine interface, and this brain-machine interface again is an implanted brain chip from the likes of Neuralink. But the reason why I thought this one was particularly interesting is a little while ago I wrote an article on how a particular patient in America who had an implanted brain chip from Neuralink, so he was a quadriplegic and so on and so forth, had actually learned how to multitask. So on the one hand, basically, he was creating art. On the other hand, he was playing chess. On the other hand, basically, he was playing, Doom and StarCraft. And on the other hand, basically, he was writing a novel. So this particular patient had learned how to use his brain chip to help him multitask. Now, when we have a think about the human brain is actually a lot more capable and a lot more mysterious than anyone thinks. So a number of psychologists got together and started studying this patient. And what they started realizing was that mentally, he had started compartmentalizing each activity. So the way our brains normally work when we multitask is it's just a giant fuzz. When you actually go into, say, an MRI machine or an fMRI machine, and we do multitasking, the whole brain kind of lights up. However, what this individual had done is he had managed to compartmentalize each task. So that's the equivalent of putting the responsibility for performing each task in its own room and then locking the door, which then sort of leads to the question of just how far can humans go when it comes to multitasking? Whatever multitasking is, learning new things, doing other things. How far could we go if we could learn how to compartmentalize all of these different activities? So this is an interesting article from my viewpoint, because it could be another way that technology is helping us unleash human potential in brand new ways. So that's kind of mad. Now, the Chinese, we know that the Chinese are ahead of, for example, the United States in 38 out of 44 key emerging technology areas. Neuralink is one of the brain-machine interface companies that's seen as being sort of quite world-class. There are others that are around. But this is an interesting, this particular story here is, I think, uh, an interesting article when it comes to how we are converging different technologies together. So Neuralink, when you put a Neuralink chip into your head, Elon Musk and his team have decided to use a biocompatible material, because if you put the wrong material basically into someone's brain, then it can rust, it can degrade, it can affect brain tissue and so on and so forth. Now, what the Chinese decided to do is, rather than using a biocompatible material, they decided to wrap their brain machine interfaces, their neural implants, in genetically engineered biological cells. Now, when they actually put this into mice, on the one hand, the brain machine interface is integrated with the mice brains. So that's freaky in itself. However, it actually improved the performance of the Chinese brain machine interface by 30%, which is huge. So I think this is another example of how the Chinese are thinking quite laterally when it comes to developing new products and technologies using some quite advanced emerging technologies to outperform pretty much everything that the West is doing, and the best of the West. Um, then, speaking of this, the Chinese again recently used time crystals to create room temperature quantum computing qubits. Bearing in mind, most quantum computers have to be held at almost absolute zero. So if you think about the Google and IBM quantum computers, they have to be held at almost absolute zero in gigantic fridges in order to do their thing. Um, the US and the UK again have been freaked out because China is not really one step ahead when it comes to developing room temperature quantum computing products. I've spoken about these in the past. It's two and possibly even three steps ahead. Um, Now, when we have a look at things like digital twins, I know basically kind of a little bit more sort of boring, less sci-fi. We've got a lot of different organizations now using digital twins to do modeling of the Earth, modeling of roofs, basically in, say, cities, basically so you can figure out where to put your solar panels. We've got the US military that are creating digital twins of soldiers. So that helps them understand how healthy and fit soldiers are, but also the idea behind that particular digital twin is, if you've got a digital twin of an American soldier and the American soldier is hurt by an IED, maybe, you've got everything that you need to 3D print a new organ for them at the forward operating bases. So when we actually have a look at digital twins, increasingly we are trying to simulate planetary scale systems, but also microscopic and nanoscale systems, so that we can experiment with them and figure out, if we do A, then what happens? What is B? So digital twins are becoming increasingly pervasive, but also increasingly powerful. And it's something that I've been talking about for years. So NVIDIA increasingly is becoming a digital twin and computer simulation company as well. So go and check them out. Meta, so news from Meta again. Mark Zuckerberg and gang actually think that for artificial intelligence to become truly intelligent, it has to be embodied. Now, it doesn't necessarily mean it has to have a body like a robot, but it needs to be embodied. So we can, for example, embed AI basically into your robot vacuum cleaner. That is an example of an embodied AI. But Zuckerberg increasingly thinks that for AI to be truly intelligent, where we start reaching the point where we get to artificial super intelligence, AI has to be in something physical so that it can experience the world in a more physical and less digital centric way. And I think I tend to agree with him on that. And we've seen lots of developments in humanoid robots and so on and so forth. So a little while ago, the CEO and founder of Infosys, an Indian tech billionaire, put out the theory, or put out a challenge, that we should create a global finternet with an F. And a finternet is the internet of finance, or finance internet. Now, when you actually have a look at today's payment systems, when you have a look at the monetary rails around the world, whether it's the SWIFT network, the ACH networks, whether it's the real-time processing or payment networks, whether it is CBDCs, whether it's whatever the heck it is, BRICS Pay, etc. When you have a look at all of the different financial rails, basically that the world is actually running on, the fact of the matter is, a little bit like the internet in the 1980s, they were all discrete systems. They didn't really talk to one another. They were difficult to work with. They didn't interoperate. They were on different standards and so on and so forth. So what the founder of Infosys has put forward basically is the idea of a global finternet where you can just very, very simply plug in a new financial rail, and I can do that in the UK, and I can send money very, very quickly to somebody in the Azores, for example. And actually, I think that's a very good idea. Uh, and when we have a look at financial inclusion, um, increasingly over the past number of years, we've seen 1 billion people being brought into the financial services community and actually financially included because of innovations like this, but also other innovations. So looking at Meta now, uh, when we have a look at Meta, Meta has developed a Sapiens model. Now, again, what Meta is trying to do is it's trying to create an artificial intelligence that understands humans, human relationships, and human behaviors. And the reason for this basically is quite straightforward. On the one hand, Meta want to use AI increasingly to create human-like, authentic digital avatars and digital humans, which I've discussed before. However, if you really want AI to understand human behaviors and human relationships, then it needs to understand why humans do what they do, move in the way that we move, etc., etc. So this is all part of that kind of embodied AI and machine vision gig. So this is where, in this case, Meta actually has developed an artificial intelligence that is able to see human movement through a whole variety of different, shall we say, perspectives. LiDAR, standard sensing, so things like mocap and so on and so forth. And even though it doesn't necessarily sound, or I don't make it sound particularly great, um, there are some significant applications both in the world of sports, healthcare, business, privacy and surveillance, and so on and so forth. So it's actually a lot more significant than we think. Um, this interesting one here, I think it's interesting anyway. Um, Japan has decided, so the Japanese government has decided to work with Fujitsu and the Riken Institute in Japan to develop the world's first artificial intelligence Zeta scale, so Zeta with a Z, not Exa with an E, Zeta scale supercomputer. Now, for those of you in the HPC world, you will know basically that an AI Zeta scale computer is very different to a traditional LINPACK Zeta scale supercomputer because of the way that we actually measure basic performance and so on and so forth. However, when we have a look at the development of supercomputers just more generally, more and more supercomputers are being specifically designed and optimized for artificial intelligence, whether that's developing new models or using artificial intelligence to run different simulations basically on a supercomputer so that we can create new materials and new things. In China's case, so they can create new hypersonic weapon systems. Again, nutty story. So this one should go live in about the next year or so. But this is the first example that I have seen of an AI Zeta scale supercomputer that is actually now being developed. And then we've got this one. So Biconomy lets AI agents complete chain transactions or on-chain transactions. When we have a look at how the world of finance works today, I could transfer you money and you could transfer me money. Thank you very much. However, increasingly, we are asking artificial intelligence to act on our behalf. Now, when we have a look at things like large action models, I might say, for example, OpenAI's AI, go and order me an Uber. And it will order the Uber, but the AI, through a deferred authorization network, which is kind of like a new protocol, not only will the AI order something for me, a pizza, a cab, or whatever it happens to be, but it will take responsibility and ownership of paying for that. So on the one hand, basically, we can see deferred authorization networks actually being the new kind of payment rail. So this is where AI pays people as opposed to maybe Visa pays people. So maybe it's disruptive to Visa and MasterCard. But in this particular case, we had two bots that actually transacted with one another on chain to complete a transaction. Now, if you imagine what could happen if we let AI transfer money between different bots, or if we allowed AI, or if we gave AI authority to spend our money and any money that it has in its own crypto wallets, this is really the start of the conversation about what happens when AI can manipulate and run the entire global economy. So when we talk about the future and we talk about the things that we're doing today impacting, the possible, probable, preposterous futures and so on and so forth, this is a little story that on the one hand doesn't really seem particularly impactful. Might be interesting, but it's not necessarily impactful. But it could actually change absolutely everything about how the global economy runs. So that's it again from me. So if you want to sort of go through these news stories and lots of others, go to the fanaticalfuturist.com blog. If you want to download all of the books that talk about these technologies, like the future of smartphones and different whatevers, AI, liquid AI, etc., then go to the 311institute.com website. Have a look at the top, and you can download the latest trends books. You can download the latest emerging technology codexes. They're all free. The Emerging Technology Codex covers over 300 emerging technologies up to about 2,000 years out. There's one called Stellar Engines. Check that one out. But the technology that we have on the truck today is truly science fiction. When you have a look at the news that I've kind of just read about today, I mean, this one, genetically modified brain-machine interfaces, when you have a look, cognitive compartmentalization, when you have a look at the breakthroughs and the things that we're seeing today, there is absolutely no question that the future and even our present day makes science fiction as we think of it absolutely lame and defunct. Science fiction is already science fact. So thank you for watching this, and stay tuned basically for the next one. Take care, everyone. Goodbye.